So that is a bell-shaped curve, high in the middle, low on the ends, and it has a really fancy mathematical equation, and that's all calculus and all that. And there are ways to test if your data follows a normal curve, but we're not going to get into all of that for this class. As you know, the class goes really fast, so we aren't going to get into all that, but it is interesting, and it is in your text. You don't have to know it, but again, all you have to know is a normal curve. If it follows a normal curve, then it's bell-shaped. And we talked about previously the empirical rule a long time ago. It seems like a long time ago. I think that was like 2 weeks ago we talked about that. And just for a shortcut, it's 68, 95, 99.7. And this is approximately where most of the data lies. Okay, and again, it's just an approximation. Now, underneath this normal curve, this area under this curve is 100%. So if you color in all of this area, we should get 100%. And the area under the curve is also probability. So if you remember, with the empirical rule, I spelled that wrong, sorry. With the empirical rule, we said 68% of the data is approximately between -1 and +1 standard deviations. 95% of the data is between -2 and +2. So it went like this, approximately -1 standard deviations, +1 standard deviations. The mean was 0. Again, on a standard normal curve, 68% of the data was here. Then I'm going to change color. Then between -2 standard deviations and +2 standard deviations, all of this area, the red area, was 95% of the data approximately lie between -2 and +2. And then we had 3, and we usually don't go beyond 3 because those are way out there. Talk about that in a minute. And approximately 99.7% of the data lies between -3 and +3 standard deviations on this bell-shaped curve. So when I talk about percent, I'm talking about probability. So area, percent, and probability is all the same thing. Okay, so I could say the probability that my data point is between -1 and +1 standard deviations is 68%. Or as a decimal, you could put 0.68. But it's all the same. Probability and the area under that curve are the same thing. Okay, well, that was the empirical rule. So I want to show you the calculator that we're using this week. And the book uses tables. The tables are not accurate. Those were like a long time ago we used to use tables, and you would have to interpolate, and you don't get a real exact answer or actual answer. So I really like this calculator, and I put the link to it in the announcement. So I'm going to go to this calculator here, and it's from the online stat book. So if you just search for online normal calculator or onlinestatbook.com, if you look up here, you can see the address, right? Address bar is onlinestatbook.com. But again, I put the that link in the announcement. So if you look at how many calculators we have on the side. If you look on the left side, we're not going to use all of these, of course, but there's so many that has to do with statistics. So we use number 8. Number 8 is the normal distribution standard, standard normal curve. And with the standard normal curve, our mean is 0 and the standard deviation is 1. That's the baseline. Okay, so for a standard normal curve, we always have the mean 0 and the standard deviation 1. So I want to show you between -1 standard deviations and +1 standard deviations. If you look at our result right here, its area is the same as probability, is 0.68. That's 68%. So what this calculator does is give us the area, which is the same as probability, and we knew that from the empirical rule. We said 68% of our data was between -1 and +1 standard deviations, and the reason I like the calculator here is because you get a really good picture. It's shaded. And then we could do -2, between -2 and +2 should be 95%, 95.45. So that's about 95% of our data is between -2 and +2 standard deviations. And then -3 and +3 should be about, sorry, press the wrong button. Okay, should be 99.7, or 0.997 is 99.7%. So what I did here is just illustrate the empirical rule and this calculator that I think is the easiest way to get our answers. And I think it's the best way actually, because it has the picture with it. So again, that's just an illustration of this calculator, and I'll come back to that. So you've all heard, I'm sure, of like grading on a curve. And that's using the empirical rule actually. So grading on a curve is, I'm not sure if everybody's real clear on that, because I don't think that's how you'd want to be graded. I wouldn't want to be graded on a curve, because that essentially means that 68% of the scores should be C's, should be between -1 and +1 standard deviation. And then between 1 and 2 would be B's. And then 3 standard deviations, that would be your A's way at this tail. So on this side, between -2 and -1 would be D's, and then you would have F's here after -3. And so if we know 95% is between -2 and +2, that leaves this to be 13.6. So you'd only have 13.6% B's and 13.6% D's. And then that would leave 5%. Since that's 95, that leaves 5% for the N's. So if you divide that by 2, because you have 2 N's, then that only leaves 2.5% A's. So that's essentially what grading on a curve means if your grades follow the normal curve. And those results aren't that great. So I mean, when I say, I grade on a curve, that means I don't grade on a curve, but I look and see how everybody else does compared to the whole class, and adjust grades accordingly. But that's what grading on a curve would mean. Okay, then also in this week, we talked about z-scores. So let me talk a little bit about z-scores. And just basically what a z-score does, it takes the standard normal curve. So I'm just going to SNC. Okay, standard normal curve where the mean is 0 and the standard deviation is 1. And it translates any normal curve So you could have any mean, any standard deviation back to the standard normal curve. And that's where you would use the table. And I'll show you that you can use a calculator that way too, but you don't have to. It's even easier if you don't use the z-scores. But I'm going to do it both ways just so you can see and feel comfortable with both ways. Okay, so a z-score takes any normal curve back to the standard normal curve. Now, why would you want to do that? Well, suppose you have, and this is just one example, and I'll do this example, but suppose you have two exams. You have a math exam and maybe you have a biology exam. Okay, and they have different standard deviations and different means, but you want to compare those two test scores, see which one you did better on. Okay, you can translate each one of those into their z-scores and then compare test scores using the z-scores to see on which test you did better. So one of the ways that you would use z-scores is to compare two different test scores. So let me give you the formula for this. The z-score is equal to your score, or any score you want to translate, minus the mean divided by the standard deviation. So that's the formula that we use for the z-score. You take the score that you want to translate back to the standard normal curve, subtract the mean from the mean of your test or whatever you're going to talk about, and then divide it by its standard deviation. Okay, so let's do an example. Let's say, okay, I have a math test and I have say a biology. And say the mean on the math test was 75 and the mean on the biology test, and we don't even know if it doesn't even have to be out of 100. Okay, all we need to know is the mean and the standard deviation. Let's say the mean was 55. On the math test, the standard deviation was 15. And in biology, say it was 5. Okay, suppose your score here was 89 and your score on biology was 60. So what we want to do is we want to see which one did you do better on compared to the rest of the class. So this would be compared to the rest of the class, because the mean is from the whole class and the standard deviation be from the whole class. So we're going to find the z-score. So the z-score would be your score minus the mean divided by the standard deviation. And it's not a hard formula, okay? When we can use our calculator to do that if you want. That would be 14 divided by 15. .933. And for biology, you would do the same thing. The z-score would be your score, which was 60, minus the mean divided by the standard deviation. So that would be 5/5, which is 1. All right, so we had two different normal curves. Here, the mean was 75, and here, the mean was 55. And what we're doing is we're translating this and this to the standard normal curve. So that would look like this. Here's our standard normal curve with the mean 0. So one of our z-scores was 0.933 and the other one was 1. And so this one is better because it's further away from the mean. It's higher. So your biology test was better. And what we did was we took just two separate things and we translated it to one curve, the standard normal curve, where we can compare the two scores. And that's basically what you use, what's one of the uses for a z-score. Okay, so is there any questions on how to use this formula?
Okay, so just to make sure I understand, so let's say I had data about customers shopping for a particular item, let's say a blue shirt, and then I had data around customers shopping for some denim jeans. So with the data being different, like the sample size being different and giving me different means and things like that on the bell curve, in order to see like we're getting the probability, is that what the number is that we're supposed to be basically?
No. Okay, we didn't go that far. Okay, all we did was get the z-score that went with the cost. So suppose the shirt cost $20 and the mean cost is 25 and the standard deviation is 4, then the z-score for that shirt would be the shirt cost minus the mean divided by the standard deviation, which would be, in this case, a negative 5/4. This would be a negative 1.25. So probability isn't negative. We're just finding out the spot on this curve, this spot right, this z-score, which actually, this would be the z-score for the shirt. That is 1.25 standard deviations away from the mean, and it tells us it's to the left of the mean. So we're just finding out where, how many standard deviations from the mean are we? We're not finding the probability yet.
Okay, so what the z-score is telling us is it's taking apples and oranges and putting them on the same chart, so they're apples to apples. So we see where they fall. Okay. All right. Because I was like, wait, am I missing a step? All right. I'm with
you. It just shows you how many standard deviations we are away from the mean.
And the mean, once you do the z-score, is going to be the same for both of them.
No, the jeans could have a different mean. The jeans could be $50 with a mean price of, say, 60 and standard deviation 8. So their z-score would be 50 minus 60 divided by 8, which would be negative 10 over 8. So that would be, let's see, divided by 8. That would be a negative. Actually, it's the same. I just made that up, so right. It's funny, but so they're going to be comparable. So they have the same z-score.
Okay, and when we chart the z-score, we use just 0 as the mean. We don't.
Yes.
Okay. All right.
It's always going to be 0. Now, let me show you. You won't have a problem like this. I was just showing you. I don't want to just throw z-scores at you and you not understand. Like, you're asking really good questions. So I did this example, but next I'm going to do example like you'll have on your assignment. But I wanted you to understand that you were right. It's like comparing oranges and apples, and then you put them all together and onto a same scale. So you make them all apples.
Okay, I'm with you.
Okay. Okay, so that just shows you where it lies on the normal curve, where they each lie. Like I said, it gives you how many standard deviations away from the mean and the direction. So since it's negative, that means it's going to be left of the mean. So a problem, there's like so much. I'm trying to put it all together is what I'm trying to do. So the problem that you would have, that you would see on the homework, would be something like this. Find the probabilities. Okay, so we know it's normal. They have to tell us it's normal. Find the probability So don't overthink this because we're going to use the calculator. Find the following probability. So they use this symbol. So that symbol means find the probability that your z-score is greater than negative 1.25. So what I'd like you to do is just, kind of draw a picture. If you, first off, if you see z, okay, if you see z, that means it's the z-score. And that means it's a standard normal curve. So that means right away, your mean is 0. And then your z-score, since it's negative, is to the left. Remember, z-score is the direction and how far you are from the mean. So we're 1.2 standard deviations from the mean to the left. And I'm going to find out what's the probability that it's greater. So now we're taking it one more step and we're finding probabilities. So what I was trying to show you first was the z-score formula. Okay, here they're giving us the z, and remember z is going to be between -3 and 3. We don't go beyond 3 in most cases, because that's, at the tail end right here, and there's hardly anything there. So how would I do this problem? Well, it turns out it's pretty simple. So we're going to go to that calculator I was telling you about. Okay, the normal calculator, the mean is 0, the standard deviation is 1, and then all you have to do is decide, is it above, below, between, or outside? Outside means to the left or to the right. So we want it, since it's greater than, we want above -1.2, and that's all you have to do. So don't overthink this. And look, isn't that the picture we just drew? Look at the graph right here. It's -1.2 is your z-score. That's the point that's right here. If you can, I can't draw on this, but look at -1.2 on the x-axis. And then we want greater than that, so that would be to the right, above. And so the probability is going to be 0.8849. Okay, so don't overthink this because this calculator gives us the answer right away. So 0.8849 would be our answer. Or you can answer as a decimal. I don't, as a percent. You can answer as a decimal and just leave it as that answer, or you can answer as a percentage. I don't have a preference. Oh, okay, great. Well, this is perfect for you, Brandon. I hope this helps. There's not anything else you have to do except this. Okay, so find the probability that z is between 1.3 and 2.1. Remember, these are z-scores. So again, I'm going to draw a quick picture just to know what to expect. I always use the standard normal curve, which is 0, the mean. So 1.3 is about right here. 2.1 is about right here. And I want this area. I want the probability that z is between 1.3 and 2.1. Let me talk a little bit about the symbol. Okay, the symbol, that means between. When you have A less than X less than B, that means X is between A and B. And they always use less than. I mean, I could get into that. That's a little bit more algebra, but I think we're just going to leave it at that. This is between. You're greater than 1.3, but you're less than 2.1. So you're between those two values. When you see these symbols right here, this less than, Z, less than. That, as soon as you see that, that means between. Okay, so all we have to do is go to our calculator. Again, don't overthink it. So again, mean is 0, standard deviation is 1. How do I know that? Because it gives us our Z. Whenever it gives you Z, then that's the standard normal curve. And all you have to do is type in 1.3 and 2.1, and it gives us a really nice picture. That's the same picture that you should have drawn between 1.3 and 2.1. If you look on the x-axis, then that area represents the probability, which is 0.0789, so 7.89%. That's all you have to do. All right, let's try another one. Oh, I just automatically draw a picture. This one would be P. Probability Z is less than 1.75. All right, 0 is always in the middle. 1.75 is about here. Okay, remember, to the right's positive, to the left's negative, and I want less than, so I want to the left. Less than 1.75. This is less than. So all I have to do is go to the calculator. Okay, I'm at the calculator. Mean 0, standard deviation's 1. I want it below, because that's to the left. Below would be left, 1.75. And see oh, I did 11. Sorry. 1.75. I was wondering, see, that picture told me it was wrong. So that's why you should draw a picture first to see what you should expect. And you should see here on the x-axis, I'm at 1.75, 1 3/4, and I go to the left. It's less than that. So this shaded area is the probability, which is 0.9599. 0.9599. So another thing I want to talk about is don't round too soon. I would just write down equals 0.9599. 4 decimals is great. You know, if you're going to round it to 2 places at least, but don't say 1. Okay, so you know, use as many decimal places as they give you. The more the better, because this is going to be really precise. So does that make sense so far? We're just taking it one more step in finding probability using that calculator. You don't have to use the z-score formula. You don't have to use anything because it's already in terms of z. It already has z in it. So any questions on that? Okay, cool. All right, great. Okay, So next thing is, though, this is the question you should ask. I'm sure it's in your head. The question you should ask is, well, what if you don't have a standard normal curve? What if the mean's not 0 and the standard deviation is 1? What happens then? Well, if we take any normal curve, remember how we translate it to the standard normal curve? We use that z-score formula. But I even have an easier way. Okay, so this is what I do. I will show you both ways, but I think you'll like the easier way better. Okay, so here's an example. Okay, we're at a bottling plant, you know, where they bottle like Pepsi or Coke, and they fill bottles. So we want the mean fill to equal 32 ounces. Okay, so we're trying to fill up bottles, and you've been in a store and you've seen bottles and they're not exactly all equal. You know, I mean, it's only a minute amount, but if you look on the lines of where bottles are filled, they're not all equal. Some are a little higher, some a little lower. So, you know, you can't always be precise and exact, although companies try to do that. So we want a 32-ounce bottle. We want to fill it with 32 ounces. Well, that's not always going to happen. That's going to be the mean, and the standard deviation, we only want 0.2 ounces for our standard deviation. So for these problems, they have to tell you those numbers, okay? You don't make them up or anything. They will give you the mean, and they will give you the standard deviation. So let's see. Okay, so what's the probability a bottle has less than 32 ounces? Draw a picture. Again, these are all normal, okay? It'll tell you that these are all normal, so you draw a bell-shaped curve. Means 32. Well, I wanted to ask this question just so you can see. You don't even have to go to the calculator. I hope you can see that. The reason you don't even have to use your calculator is because if 32 is mean and we want less than 32, well, that's half the curve. Okay, so you should be able to see that the probability that it's less than 32 is 50% right off the bat, or half. It's half the curve. But if you want to go to the calculator, what we do, okay, remember these two numbers, 32 and 0.2. We're going to go to the calculator, the one we're going to use. And then instead of the mean, we don't need the z-score. Instead of the mean being 0 now, it's 32. And our standard deviation, instead of being 1, is 0.2. Okay, now that will be given in the problem. And then I want it less than 32, so we use below. That would be to the left, and we should get 50%, which we do. Look, half the curve, 0.5 is a half, or 50%. So now we don't have to do the z-score. We can just plug our new mean in with the new standard deviation. That is 0.2. And then we wanted it less than 32, so it would be below 32. And we get 50%. But you can see that's half the curve. And that's why I like this calculator, because it gives us a really nice picture. All right, but you're saying, well, what if we use the z-score? Okay, well, if we want to translate this to the standard normal curve, this is the second way you can do this. Now, you just pick one way. It doesn't have to be that way. We're going to translate, this is just more work, standard normal curve. Using the z-score formula, remember we take our score minus the mean divided by the standard deviation. So our fill was 32, the mean was 32, standard deviation was 0.2, so that's 0. So on the standard normal curve, the mean was 0, and we want it left of 0. So you still have to go to the calculator. Sorry, all this jumping around, but go to the calculator and you leave the mean as 0 and the standard deviation 1. We're back to the standard normal curve. We want it below 0, which was our z-score, and we get 0.5. We get 50%. So that's more work. You don't actually have to find the z-score to do these problems. You can just plug in your new mean and your new standard deviation, and it works out the same answer. But I just wanted to show you that you can take any normal curve, use the z-score formula, and translate it to the standard normal curve to get your results. Either way you do it is fine. I like, of course, the easy way. So let's try another one just to make sure you understand. It's the same bottling company, but now we want the probability let's see. That the amount's greater than 32.1 ounces. Probability that the amount that the bottle has is greater than 32.1 ounces. So remember, it's greater than, that would be to the right. Go to our calculator. Means 32. Our standard deviation was 0.2 or just 0.2. And we want it greater than, so in this case, it would be above 32.1. And look at the picture. Okay, we didn't have to find the z-score. The mean's in the middle. 32.1 is on the x-axis right there. We wanted greater than 32.1, so that's to the right or above. And our answer is 30.3085 or 30%, 31%. Actually, I want to say 30.85%. We want to be precise. So the chances that we get more here's 32. Chances we get more than 32.1 is 0.3085 or 30.85%. Now, if you want to do the z-score method, which I'm not trying to confuse issues, but I just wanted to show you what the z-score formula will do for us. You take our score minus the mean divided by the standard deviation. So we get the z-score for this problem. Which is 0.1 divided by 0.2, that's 0.5. And then we use a standard normal curve. and we want it again greater than that. So, and we don't have to do it this way. We already got the answer, but I'm just showing you that you get the same answer. So let's go back to our calculator. This time we have the standard normal curve, 0 and 1. We want it above the z-score, which was 0.5. We calculate. Notice we get the same answer, 0.3085. We get the same picture pretty much too, but remember our mean was 32. So what I'm trying to say is that the z-score translates it to the standard normal curve, and then we use the standard normal curve where the mean is 0 and the standard deviation is 1 to get our answer. But you don't have to do that. You could just say the mean, we know is 32. The standard deviation is 0.2, and immediately you could just say, what are the chances it's above 32.1? And that is a quick way to do that, and there's nothing wrong with doing it that way. All right, let's try one more. Same problem. Probability the amount is between 31.5 and 32.5 ounces. So that would look like this. Probability, your amount is 31.5 less than the amount less than 32.5. Okay. Now, the reason that I'm not going to do the z-score on this one is because you'd have to do the z-score for each one and then subtract those areas, and then it gets really complicated. Well, actually, you wouldn't. You would just have to find the z-score for this one and the z-score for this one and do it between. But why do all that work? We're not going to do all that work. We're just going to go immediately to our calculator. Well, first, let's draw a picture. I always like to draw a picture. 32 in the middle, 31.5 is on the left, 32.5 is on the right, and I want this area here. Probability is the area. Okay, so go right to our calculator. Mean is 32, standard deviation is 0.2. I want it between 31.5 and 32.5. And it's 98.76% or 0.9876, however you want to answer it. So you immediately get an answer without doing any work. You don't have to find the z-scores. Again, if you wanted to do the z-scores, you would just go back to the standard normal curve and find the z-score for 31.5, find the z-score for 30.5, and it would give you the same answer. That's a little too much work. I just want to go right to this and type it in just as it is. 0.9876. And look at the picture. Our z-score on the x-axis is 31.5. This is 32.5. If you noticed how the x-axis is labeled, that picture is really, really nice. So the answer to that would be 0.9876 or 98.76%. So the whole, let me make sure you understand that the whole area under here is either 1 or 100%. So if you want to do decimals, you don't have anything bigger than 1 if you want to do percent, so you don't have anything bigger than 100%. So that's basically the assignment. Let's see. It asks you about Z-scores. It asks you about probabilities with the standard normal curve and without the standard normal curve. And then it talks about the central limit theorem, but I don't want to talk about that yet. I want to make sure if you have any questions about the calculator or about what I just did, if you want to see more examples. So again, this calculator, normal distribution calculator, is number 8 on the left. And if you look at the address, it's onlinestatbook.com. But I put the link in the announcement. And when I post this video, I'll also put the link in for this calculator. There's many out there. You don't have to use this one, but I just like it because it has the picture. I'm just looking at the assignment. Okay, well, while I'm waiting for your questions, I just want to go over what we talked about. Again, we talked about the empirical rule, 68, 95, 99.7. We talked about the Z-score formula, where you take your score minus the mean divided by the standard deviation. We talked about that we could take any normal curve, translate it to the standard normal curve with the Z-score. The Z-score does that for us. And the standard normal curve is the curve that has mean 0, standard deviation 1. And then we talked about how to use the calculator. So is everybody okay up to this point? Okay, good. Yeah. Catherine, any questions, any Charity? Okay. All right, so let me talk about the central limit theorem. Again, I'm trying to focus on exactly what you need. There's so much material in here. And this is the most important theorem in statistics because it says that if you take a lot of samples, the sample means, and this is just really, really basic. I mean, you need to read about it. Okay, I'll do a little research on it, but I'm just going to do one sentence deal on it. The sample means form a normal distribution. That means it's a bell-shaped curve. Even if original is not normal. Okay, so what this means is the more examples you take and you get their mean, just pull the means from all these examples and graph them, you will get a bell-shaped curve. So I found this really neat article. I think that would help. So I'm just going to show that to you. It's not an article. It's an explanation really quickly. It's better than what I can do. So I found this central limit theorem. It's from, I can give you the link for it, but I just want to show you a picture because it's a lot easier to explain with the picture. The mean, they use the same mean as the population, but for the standard deviation, you divide it by the square root of n. Now, I have a short video explaining that. I don't want to get into all the math about it, but you can ask me about that later, but I'll send out that video that explains where that square root of n comes from. But just for what I want to do here is to show you pictures, because I think pictures help a lot. So here's the example they take. Okay, here is the population of retired Americans. So if you're retired, they did a survey, and here's your age at retirement, and it shows that there's some people that retire at 40 and 50. Most maybe retire at 70. So this is left skewed. Okay, the tail's on the left, so it's left skewed. Now that's not really normal. Okay, and they only took maybe a few samples, so we didn't do a lot of samples here. So left skewed. All right, here's a really small example of 5. And the mean was 67.2. But here's another picture. Suppose you do this many, many times. Okay, look at how the picture, these are the mean ages of retirement of a lot of samples. So what's happening between here where it's left skewed and here where it's becoming more normal is that they're taking more samples. So they're graphing the means of all the samples. And then if they take a lot, they took a sample of 50. So the sample size is getting larger and the number of samples are getting larger, and it's forming more of a bell-shaped curve. So they're graphing the means. So I thought that was a really good picture or way to show you what's going on. So what exactly what they're doing is taking all these samples, okay, taking the mean out of each sample, graphing it, and it's going to form a normal distribution. So the more samples, the better. And the more the size of the samples, the larger the samples, the more normal it's going to be. But this is the important part. The population doesn't have to start out normal. Like you saw in the retirement example, it was left skewed. Most people retire in their 60s, late 60s and 70s. So real important theorem. Okay, good. I'm good. So yeah, Catherine said there's a video in the additional readings. So I try to put a lot of videos in those supplemental readings. So if you don't want to read the text, I'm trying to put supplemental material in here to make things a little easier. So there has been other videos that have been done. So thank you for pointing it out, Catherine. Okay, so for an example, and this will be my last example, but suppose there are 250 dogs at a dog show. Okay, so that's the population. And it doesn't say anything about it being normal. And their average weight is 12 pounds. And the standard deviation is 8. So we're going to take example. And in the readings, you'll see that the sample size in order to use this should be bigger than 30. But that's a lot of times ignored. So don't, worry about that too much. But they're saying that the sample size should be bigger than 30. So we'll take a sample of 35, and we want to know the probability that the sample mean is between 8 pounds and 20 pounds. Now that's a big range, but this is just an example. You could say anything here. I mean, I could have made up any numbers, and it's going to work the same way. So how do you know that this is a central limit theorem? Okay, it's a central limit theorem just because of the wording right here. You're trying to find the probability of the mean. So you're not finding the probability of a weight. You're not finding the probability of a height. You're finding the probability of a sample height. You're finding the probability of the sample weight of the sample that you took. Okay, so that is how you tell that this is the central limit theorem. And what you do, the mean is the same as the population mean. So here you're going to use 12. The standard deviation, though, is different. You're going to use the standard deviation divided by the square root of n. And n is the number of things in the sample. So n is the number in the sample. So in our case, standard deviation was 8. And we had 35 in our sample. Again, I'll send a short video on why we divide by the square root of n, but it just gives us a better representation for the sample. The square root of n, it actually comes from the variance. The variance of the population and the variance of the sample are inversely proportional in the size. But again, that gets into more math. But Khan Academy has a really good video on that, so I will send that out also if you're interested in why we do this. Okay, but so far, this is what I have. So I'm going to use my calculator here. And I get 1.352. I like to go 3 or 4 places. Okay, so now what I do is I'm going to go to the calculator, go to the normal calculator. All right, I have a normal calculator, and let me just erase all this. So we start fresh. You don't have to, but we're going to start with our mean, which was 12 pounds. Our standard deviation is 8 divided by the square root of 35, which was 1.352. And we want it between 8 pounds, we said, and 20 pounds. What's the probability our sample mean is between those two values? So we look at the picture, and it's almost certain. It's 99.85%. 9985. So again, you plug in the mean, whatever they give you for the mean, it's the same, but the standard deviation, you divide by the square root of n. So that's going to be different, but everything else is the same. So we want the sample mean to be between 8 and 20 in our problem, and we get 0.9985. Okay, so use the mean to be 12, use standard deviation to be 8 over square root of 35, which was 1.352, and we wanted it between 8 and 20, and it was 0.9985. So almost 100% chance that our sample mean is between 8 and 20. So again, this was the central limit theorem. The mean's the same. The standard deviation is the standard deviation divided by the square root of n. N is the sample size. And the reason you know to use it is because they ask you that for the probability of a sample mean, or the mean of the sample. Or the mean, they say the mean of the sampling distribution, which is the same thing as probability of the sample mean. Okay, so that was kind of quick, but that's the kind of questions you'll see. And you can use the same calculator, and don't overthink it. This is the only thing different in what we've been doing. You have to divide by the square root of n. Okay, and that basically covers everything on your assignment. But if you want to get on Collaborate, just let me know. If you run into a problem, you can redo any assignment, or you don't have to redo it, just correct it. And if you want, you could send me the assignment, email me your assignment. I can look it over before you submit it. I'll do that too if you want. So when I say redo, you don't have to redo the whole assignment, just correct if you want to correct. But you can email me, text, call, or if you need to get on Collaborate again, just let me know. I know I felt like I was talking a lot, but I'm sorry I talk so much. If you have questions, just let me know. And we had a lot of material this week, but don't overthink it. Okay, anything else? Oh, thanks, Catherine. Yeah, and if you want, like I said, if you need more help, I'll get on and Collaborate with you. You just let me know, give me notice, and we'll make an appointment. Okay, you too. Have a great night, and I will post this as soon as it publishes. And if you need more, like I said, let me know. I'll help you, whatever you need. All right, good night, everybody. I'll send a link out in a few minutes. It takes a while to, like I said, publish it.